Hello everyone. So today I'm going to cover two questions which are related to lexicographically smallest string. Okay. So these questions are like we have to do some operations on given string. You'll be given some operations and that could be anything. Okay. And after doing certain type of operations, the string which you will get should be lexicographically smallest. Okay. So for this first question, given string num representing a non-negative integer num and an integer k, two things are given, one string num and another integer k. We have to return the smallest possible integer, but as is a string, so we have to return the smallest possible integer string after removing k digits from num. Okay, so the question says that we can remove k digits from this num, and these, after removing this k digits, this should be smallest lexicographical string. Okay, now to make smallest lexicographical string, okay, to make a smallest lexicographical string, we have to fill the stack in monotonic increasing way. I hope you agree with me. Why? Because what does this mean? Smallest lexicographical string means what? Let's say this is 1. Okay, I've taken 1. Then I've taken 4. And then when 3 comes, I need to remove this 4 so that this is smallest. 1, 4 and 1, 3. Which is smallest? 1, 1, 3, right? 1, 3 is smallest. So whenever a number, so the pure concept of one thing to understand is when a number smaller than any previous numbers are coming, remove those previous numbers, right? Remove those previous numbers. And this we are doing in previous smallest integer. When we have to find previous smallest integer. Okay, so it's nothing but the code is similar to previous smallest integer. In previous smallest, what are we doing? While the stack is not empty and the top value is greater than current element, which is array of I, we will pop it out from the stack. And the same thing we have to do here. But how you will get to know that previous smallest? Because when can we make smallest lexicographical string? When can we make smallest lexicographical string? Smallest lexicographical string means it should be one, if there is 1432219. Okay, and it says that you have to remove three numbers. Okay, so the first thing is, rather than 1413 is good. So when 3 will come, I'll remove 4. So now I have 1 3. So when 2 will come, okay, what 2 will say me? That 1 2 is better than 1 3 2, right? So I'll remove again this 3 and I'll make it 1 2. Now again this 2 will come, fine, I have no issues. When this one will come, again I'll remove this 2 and this 2, because if I remove this both 2, then it will be 1 1. If I won't remove this 2's, then it will be 1 2 2 1. So 1 1 is smaller than 1 2 2 1. Okay, 1 1 is smaller than 1 2 also. This is the lexicographically smallest string. The first number which is smaller in any string is lexicographically smaller than other string. Okay, but we can remove only 3. So here the condition is of k. Here the condition is of k, that we have to remove only k digits from the nums. So this condition we will do until what time? Until k is greater than 0. So there is some third condition added over here, which is k greater than 0. While popping it out, we will decrease k also, because we have popped means we have removed. And finally, whatever your string will be there in the stack is your answer. But now the question is, let's say you are given this string and your k is 2. Okay, so 1 2, when 3 will come, all are smaller only, 3 and 4. I don't feel anything to remove, so there is no other smallest string I can make out of this. Okay, so when this condition is occurring, when you didn't have any choice, any smallest string, okay, better than this, then what we will do? We'll try to remove from the back until our k is greater than 0. So after filling up this stack with this method, with this previous smallest code, If our k is still greater than 0, still there are some k left, still there are some operations left, and we need to make the lexicographically smallest string, we will remove it from the end, because anyways this will be our increasing string only. It will be monotonically increasing string only. So we'll try to remove it from the back. We'll try to remove it from the back. How many k's are left? That much elements we will remove from the back. And there is some other third condition is like you will be given 10200. Okay, and you need to make the smallest lexicographical string, and your k is 1 only. Okay, so 1, when 0 will come, you will remove this one. So now your final string is 0200. Okay, this is lexicographically smallest, but again we cannot consider this 0. So while returning, we will return only 200 and not 0200. So we have to remove all the zeros which are there previously in our stack, which are there previous in our stack. I hope you got. So while removing, after removing from the stack, we'll make a string. We will reverse it, because reverse is our correct answer. When you will pop, you will get 0020, but we will reverse, then you will get 0200, and then we will remove this first 0, and we will start from this index and push back the whole string as it is. I hope you got my points. Okay, so let's inculcate this point and write the code directly in the Leetcode. Okay, so this n is num dot size, and we have one stack of character st. You also have a k. Okay, what we will do first, while no, we'll traverse. Okay, we'll traverse for int I is equal to 0, I less than n, I plus plus, while not stack dot empty, and the element on top of the stack is greater than current element. Current element is nothing but num of I, and our k is also greater than 0. Then in that case, we will pop it, and we will do k minus minus. And anyways, we will push the current element in our stack. Okay. Now, the thing is to remove the elements if the k is again greater than 0. So while not stack dot empty and k greater than 0. So until that point, we will pop from the stack and we will do k minus minus. Now we will have one string answer while not stack dot empty, answer plus equal to stack dot top, sorry, stack dot pop, answer plus equal to stack dot top, stack dot pop, and we will reverse this, answer dot begin, answer dot end. Now we will remove the characters if there are zeros in the front, like this example. Okay, leading zeros we will remove. So we'll have one idx which is nothing but 0. Okay, while idx is less than n, if n is nothing but, while idx is less than answer dot size, if answer of idx is equal to 0, we will do idx plus plus, else we will break. Okay, so that particular, from that particular idx to end of the string, our string is correct. Okay, so we'll make this answer as empty again, and we will traverse from idx till, oh, we'll have, okay, we can take from idx to n. So we'll have one string result for int I is equal to idx till I less than answer dot size I plus plus, result plus equal to answer of I, and we will return this result string. I hope you got. So there are two cases which we have to think differently after doing this also, and that is nothing but this thing. So if it is left with nothing, which is 0, so we need to return the 0. So if result is equal to empty, then result is equal to 0. That also you have to 2. That is our third case which they have returned. After removing all, if it is left with nothing, then you return the 0. Okay. Now there is another question of similar kind. So let's just solve that too. This is little bit hard where you have to think conditions in a separate way. Okay. So the question says that you are given a string S, and again the condition is to remove duplicate letters so that every letter appears one and only once. You must make sure your result is the smallest in lexicographical order among all possible results. Okay. So the question says, if this is your string, your answer should be equal to ABC. If BC, ABC, you need to remove the duplicate letters and take it only once. And that too you have to take in such a manner that the final answer is lexicographically smallest. I can take this also, BCA also. But that is not lexicographical smallest. Lexicographical smallest is ABC. Even I can take CAB also, but that is still not lexicographical smallest, the CAB string. Okay. But so you have to take in such a way that it is smallest in lexicographical order. CAB also I can take, right? BCA also I can take. That is also correct in correct order only. You have to take it in order. But in order also there are so many ways to take it. So you have to take the lexicographically smallest string. Again, the same condition will occur over here. That okay. Let me take the pen. That if you are traversing and you have found A, okay. So when A will come in the picture, I will remove B and C. I will remove first C and then B. Okay, because those are greater than A for making lexicographically smallest. For making lexicographically smallest string. But the question will arise, when will I remove? Does this satisfy the condition that when A is coming I have to remove? No. Smallest in lexicographical I have to do, but I have to consider that one time that should come. Okay, the C and B should come one time or one time. If it is not coming any of the time, then again it is wrong. Okay, so I am sure that I have to maintain one frequency array, which is the count of all alphabets. Okay, so if the frequency array of this, so when A will come, okay, I'll see that element on the top, which is C. I'll check if the frequency of C is greater than, if the frequency of C after removing this C. So if the current frequency of C minus 1, why minus 1? Because I'll remove this C. So if after removing this C also, if the frequency is greater than equal to 1, so is there any C on behind of A which I can include so that I can remove this previous C? Yes. If it is yes, then only I will remove it. Then only remove it. Otherwise not. Okay. So, okay. Now you are comfortable with the frequency array. Okay. So for B, C, A, B, C, we have B as frequency 2, C's frequency is 2, and A's frequency is 1. Okay. Initially when B have came, I have pushed it into the stack. Okay. When C have came, I have pushed the C into the stack because B is again smaller than C, so I'll not remove. Now when A will come, I'll see that C is in the stack, which is greater than A, and also the C's frequency is 2 minus 1, which will still remain 1. So there is one C on behind of this A, so I'll remove this C. Same thing for the B. This frequency minus 1 is again 1. So I have one B behind this A, so I can remove this B also. And then I'll push A, then I'll push B, and then I'll push C. So I'll get this ABC string. Okay. But now, consider the case. Okay. Consider the case of ABC, ABC. Now what you will do? Okay. You have pushed A, you have pushed B, you have pushed C. No problem until this because this is still monotonic increasing. Just observe the pattern of the stack storing. Stack is storing it in the monotonically increasing way. But now that this A have come, I will remove, anyways, the C's frequency is 2, B's frequency is 2, A's frequency is also 2. Okay, so I'll remove this C because I have a new C on behind of it. Fine. I'll remove the B and I'll push A. Is this correct? Pushing this A? No. So we have to push it into the stack only if it is not there. This will come for same characters. Okay, so when A is come, A is already in the stack. Okay, why will I push this A? I'll not push this A. So to store to store how many elements are there in the stack, to store number of alphabets already taken. Okay, the alphabets in the stack are taken alphabets in the final answer string. So to store number of alphabets already taken, we will have another array called as visited array. Okay, so I'll mark this visited of A as plus plus whenever I'm pushing it into the stack if it is not visited. Okay, so now when this A will try to, whenever I try to push it into the stack, this visited of A is already plus plus, so I cannot push this new A into my stack. Okay, but I have to remove the frequency of A because I'm not taking it, but still I'm bypassing it. Okay, I'm not taking it, I'm bypassing it, so I have to decrease its frequency at least. Okay, again, three things are taken into the consideration: make, frequency array, visited array, and a stack. Okay, initially frequency will store total count of all alphabets. Frequency will store total count of all alphabets. Okay, visited for every alphabet is 0. Visited is 0. Okay, traverse the string, traverse string, same. If while not this stack dot empty, and if current element, which is stack dot top, is, okay, we'll do it minus A, is greater than this current element, which is nothing but answer of string of I, and when we will remove it, if after removing this its frequency is again 1, so and frequency of this element, which is what, stack dot top, minus A, because frequency we will store it in a zero based indexing, right? So frequency of stack dot top minus A minus 1, this whole frequency minus 1 is greater than equal to 1, then only we will do stack dot pop, and frequency also, frequency of stack dot top minus A also minus minus. So I'll decrease this frequency. Okay, now when we have to push it, we don't have to push directly. If it is not visited, if not visited, which element? Current element, which is str of I minus A. These all are arrays, that's why we have to do minus A, because it will convert it into string. So A minus A is 0, B minus A is 1, so 0 1 2 3 until 25 you will get for Z. So if it is not already visited, we'll make it visited, so we'll push it into the stack. Visited we will become 1, and we will push this str of I into the stack. Else, if it is already visited, then what we have to do? As we are not taking that particular A, we have to just remove its frequency. So we will remove frequency of str of I minus A to be minus minus. I hope you got. Okay, so let's just solve it now. Okay, so we have int n is equal to s dot size. We'll have two arrays, frequency of size 26 and initially 0, and visited also of size 26 and 0. Okay, and one stack of character st. Frequency for int I0 I less than n I plus plus. Frequency of s of I minus a plus plus. So now that I have stored the frequency as total number of count of each alphabet. Now for int I0 till I less than n, while not this stack empty and current top element, so stack dot top minus a is greater than current element si minus a, and frequency of top element minus 1 will be greater than equal to 1, then only I'll pop it and I'll make this frequency of stack dot top minus a decrease by minus minus. Okay. If not, now for pushing it into the stack, we have to condition if it is not already there in the stack. So if not visited, which element? S of I minus a. If not visited, then I'll push it S of I and I'll make its visited also as 1. Okay. Else what we will do? Okay. One thing, when we have pushed it for the first time, this b, I have made it visited. Okay, so when you will remove it, you have to do visited of stack dot top minus a as 0 also. Okay, because you have made it visited when you will push it. Okay, else what we will do, we'll just decrease the frequency if we are not taking it. Now nothing, you have to make an answer array, and while not the stack dot empty, we'll take it and pop it, and we'll reverse and return it, right? We'll reverse the answer dot begin, answer dot end, and we will return. Okay, so for both these questions, we have seen that the elements which are stored previously, that we have to remove depending on the current element which is coming. Okay, related to previous smallest, whatever we have the code written. So stay tuned for the next video. Next video will cover some more new tricks, new topics related to monotonic stack and how you can solve it. I'll post this question links in the description below and you can solve it. Stay tuned, stay safe. Bye bye.